So let's go. In addition to the widely recognized repeater and intruder rooms, Burp incorporates several lesser known modules. I kind of know what we're going to do. I remember. I think it's like encoding stuff or things like that, right? This will form a focus for this room's exploration. The spotlight will be on decoder, comparer, sequencer, and organizer. These facilitate operations with encoded text, enable comparison of datasets, allow the analysis of randomness with captured tokens. Okay, so if they're not random, we can use that. And help you store and annotate copies of HTTP messages that you may want to revisit later. Although these tasks appear straightforward, accomplishing them with Burp can substantially save time, thus emphasizing the importance of learning to use these modules efficiently. Without further ado, let's delve into the first tool, decoder. Deploy the machine, we did. So, decoder. Sorry. The soap, it made me like burpy. I'm actually going to close Burp again, so we have a clear history here. What? Oh, it still remembers that that page. I'll just take a headache pill because my headache is back. It's from Car Crash 2004, which is very annoying. But it's not usually. I just trained too much yesterday, so today I feel it. The headache and stuff. Also, I did that, with the round with the neck and things. I shouldn't have done that either, I think. Well, sometimes you're stupid, or rather, I think I need to train anyway, and then we'll see what happens afterwards. I hope it's not like a week. It's just one day, I hope. The coder module of Burp gives user data manipulation capabilities. As implied by its name, it not only decodes data intercepted during an attack, but also provides the function to encode our own data, prepping it for transmission to the target. Decoder also allows us to create hash sums of data, as well as providing a smart decode feature, which attempts to decode previous data. Tell me when I'm on the wrong screen. Attempts to decode provided data recursively until it is back to being plain text, like a magic function in CyberChef. And if you haven't seen CyberChef, this is a link you should save. It's good. You can do stuff. I'm kind of curious though. I don't think I've used the magic function. Do you see the magic function? Is it the auto bake they mean? Probably, right? Whatever. To access the decoder, navigate to the decoder tab from the top. Let's start burp again. So, decoder. Oh, it's kind of tiny. I wonder if I can do anything. So, when we were here, did you have better size, right? I think I've changed some sizes. Well, we'll see what it says here. This interface lays out a multitude of options. They had two. This box serves as a workspace for entering or pasting data that requires encoding or decoding. Consistent with other modules of Burp Suite, data can be moved to this area from different parts of the framework via Send to Decoder option upon right-clicking. At the top of the list, on the right, well, there's text and hex. I guess they will say where far yeah, text or hex. Byte values. As we move down the list, drop-down menus are represent to encode, decode, or hash the input. The smart decode function located at the end attempts to auto-decode the input. Upon entering data into the input field, the interface replicates itself to present output of our operation. You can then choose to apply further transformations using the same options. Okay, smart decode. This is very much repetition, so I'm kind of feeling I should go quicker, but also I don't want to skip ahead since well, you know, you're here too. Decoding and encoding with decoder. Now, let's examine the manual encoding and decoding options in detail. These are identical whether the decoding or encoding menu is chosen. Plain refers to raw text. URL encoding is utilized to ensure a safe transfer of data in the URL of a web request. It involves substituting characters for their ASCII character in hex format, preceded by percentage symbol. This method is vital for any type of web application testing. I should actually have like a list of these characters, right? The common ones. You can like have a printed sheet even. I don't have anything like that in my notes even. Though it's easy to just do it in Burp or anything, but I'm going to actually add this to my notes now. So URL encoding. So I'm going to put the common ones here, but not right now. But like, let's add an example so I know later what I'm thinking of. So we can use this decode as URL. And let's, if we do equals, what? There. So this is equals. What? I did Control C, not C. Undo doesn't work. This is so annoying. I can't even right click copy. Trying again. Now I think Control C worked. I really hope my my control key isn't. That wasn't the first time. That it isn't broken. So I feel like I should eat something more like a sandwich too or something. Maybe something you can chew actually. Those were tiny pieces of broccoli in that soup. And it also was like extremely salty. I'm actually going to do a quick getting more lunch break. I'll be right back. Maybe some tea. Some more lunch. I shouldn't leave, I know. Always halving the number of people. So I'm just updating to Burp there too. So yeah, this I'm simply going to skip what I think is too obvious to read. So I'm curious what their link for base64 is. What? No, that was not interesting at all. So, no. Something is off. Okay. I scrolled and everything, nothing happened. I've done that in Python already, so... Oh. Let's drag this to the end, so we don't tap into open invoices. So, ASCII hex. Okay. It's kind of funny that it could do gzip compression. So let's test it with actual text. I want gzip in text. So these methods can be stacked, yes. Hex format, smart code. Okay, I have done this before, so it's a bit too, and also, you know, it's just general knowledge. And we want it to be base64. So I would like a copy button, because that's what you usually do, right? Copy and paste. So I'm just submitting it. Then we have a URL encoded data string, and we're going to encode it as plain. Well, I guess decode URL. Oh, I failed my copy. Do Control C it again. There. Smarty code. Oh, that's cute. Oh, it wanted us to smart. Okay, 47. We can type 47. Encoding challenge. Start with base 64. So, pasting it. And apparently I failed to copy again. Or I failed to paste. I tried to delete it all. I couldn't. It annoys me, you know. Encode as base 64. Convert it to ASCII hex. Convert it to octal. And then I would like a copy button. There. So now it's going to be hashing instead, which is the difference is that encoding you can reverse it. You can't reverse hashing. So do we have to read this again? No. So I'm thinking let's just go to the questions. We know that they are used to secure passwords. A hashing algorithm output does not yield pure ASCII Unicode text, hence it's customary to convert the algorithm output into a hexadecimal string. That's what we're familiar with. Let's compare this by applying the ASCII hex encoding on the hash sum to create a neat text string of this example. So, using decoder, what's a SHA-256? Hash sum of the phrase. Let's get hashing. So, copy. And now we want to hash it to... Oh my. Can I type letters? No, because it just is in the string. So I have to scroll. Well, Oh. Well, I guess it's, since I have a bit of a headache still, I guess it's a good thing to do these easy questions today. I don't know. I mostly get bored. Right, so something went wrong with my pasting there. Something is very off here. supposed to be this character. And changing it also changed the... It removed this bit. What if I just wanted, like I did this time, to just change one letter because it was a... oh, I pasted it in the wrong place. So when I copied this became the Swedish letter Ä. So apparently there was a bit of a bug there somewhere. Generate the MD5 hash sum of the phrase. Insecure algorithms. So yeah, got orange juice. So I'm kind of thinking, let's do this quickly and let's do something more fun. But I want to finish them, so MD4. Alright, hash. MD4. Encode this as base64, not put ASCII hex. So we have to copy it again. Apparently my copy failed, and it's not possible to right click it. Yeah, I remember why I will never use a decoder. Like, seriously, right click copy? No, can't right click anything here. Not possible. Here I could do it, because it's in the other mode then. So if I go to hex here, then I can copy. They forgot to put copy into the normal text one. Whatever, I'm not complaining here. I guess I am. Let's look at the in-context example. First, download the file attached to this task. There's a file. Okay. Well, I'm kind of thinking... My god, do I seriously have to do that? Let's see what they want us to do. Hashing is one-way process that transforms data. For a function to qualify as hashing, the output it generates must be irreversible. A proficient hashing algorithm ensures that every data input will generate a completely unique hash. For instance, using the MD5 algorithm to produce a hash sum for the text MD5 sum returns, using the same algorithm to MD5 sum yields entirely different hash, despite the close resemblance of the input. Therefore, hashes are commonly used to verify the integrity of files and documents. Even as a tiny... Okay, so they want us to check the checksum for the set then. Tiny alteration. Note. Algorithm is deprecated and should not be used. Moreover, the hashes are used to securely and more store passwords since they are one-way hashing. Possible. Even if the database is compromised. When you use a created password. Okay. I was somewhere else, right? I was down here. Why did I continue reading up there? So, download the file attached to the task. This file can also be downloaded from the deploy VM. Okay. Now read the problem specified. Hello.
VR Mechatronics says, hello, on next one English improve lesson.
Yeah, I have that file here somewhere with my words I learned yesterday for the English. If that's what you meant. I apparently didn't know the bookkeeping terms in English. And also other things. Like body parts. You might find this some joker has messed with my SSH key. There are 4 keys in. Oh.
I have to learn more and listen because I forget too much.
Okay. Yeah, just practice English, that's good. I had problems with the English words. Let's see. Here, English. I didn't know these were things. Well, some of them I kind of knew, but you know, this in Sweden we have like 4 words for that all translate to this in English. So I didn't feel really sure about it. But the accounting template, you know, and that we call it like in walking balance, incoming balance, and it's called opening balance. Well, not normal words. So I seriously not
I no
want to
longer
redo
stock.
this one. Yeah, I was like, what is it called? I'm more like, and when I saw it, it was like, of course, yeah, that's it. So this zip file, I already clicked this. No. So, oh well, wasn't anything. It's all I tried the AI music thingy, but it was a few weeks ago now even. I should do it more. So for this we use this tool. Old but good. Oh. Well, whatever. Let's go to... Actually, I think it's right. It has downloads here. So, what was it wanted? MD5? Yeah. But didn't it do all of them? Oh. I thought you could do it all. Okay, let's okay, apparently I didn't read what I was actually doing. Maybe this was not the quickest way. So let's do that instead. So we should have... Okay, I know what the problem was. I should have F3'd, I shouldn't have... Okay. I clicked and it checked the checksums and they were okay. Because I just clicked enter on it instead of F3 to view what it was. So 31, 66, 22. I guess it's number key 3. Yeah. So, next. Comparer. It compares stuff. I think I actually used this once. But it's this Windows 3.1 feel of this, really. Like I couldn't right click the other one. Seriously, let's do this.
The interface can be divided into 3 main sections. On the left, we see the items to be compared. When we load data into Comparer, it appears as rows in these tables. We select 2 datasets to compare. On the upper right, we have options for pasting data from the clipboard, paste, loading data from a file, load, removing the current row, remove, and clearing all datasets, clear. Lastly, on the lower right, we can choose to compare our datasets by either words or bytes. It doesn't matter which of these buttons you select initially because this can be changed later. These are the buttons we click when we're ready to compare the selected data. Just like most Burp Suite modules, we can also load data into Comparer from other modules by right-clicking and choosing Send to Comparer. Once we've added at least 2 datasets to compare and press on either words or bytes, a pop-up window shows us the comparison.
Well, let's lazy this one too.
This window also has 3 distinct sections. The compared data occupies most of the window. It can be viewed in either text or hex format. The initial format depends on whether we chose to compare by words or bytes in the previous window, but this can be overridden by using the buttons above the comparison boxes. The comparison key is at the bottom left, showing which colors represent modified, deleted, and added data between the 2 datasets. The Sync Views checkbox is at the bottom right of the window. When selected, it ensures that both sets of data will sync formats. In other words, if you change one of them into hex view, the other will adjust to match. The window title displays the total number of differences found.
So how can this be useful? Compare responses. Right, we did start something there. So, we have something to actually do. Oh, sorry. I wanted to copy. So let's try to log in with an invalid and capture. Okay. Oh, this is so annoying. Send a repeater. And let's practice the shortcut Control R. Send the request and right click on the response and show send to comparer. So there. Change the credentials to very specific ones that are apparently correct. And I assume that we're supposed to still have this up. Whatever. There. So send this to repeater. Send to repeater again. So why does this happen? Why do we get empty ones? Whatever. Send it. The response to compare, I assume, and I assume we compare these. So so if I click words, that's what actually compares it. So we go back to the login, or we send to the support. So I assume that they mean that we should look for it in more advanced things. Sequencer. I'm just switching to that one because I don't really remember this.
Sequencer allows us to evaluate the entropy or randomness of tokens. Tokens are strings used to identify something and should ideally be generated in a cryptographically secure manner. These tokens could be session cookies or cross-site request forgery, CSRF, tokens used to protect form submissions. If these tokens aren't generated securely, then, in theory, we could predict upcoming token values. The implications could be substantial, for instance, if the token in question is used for password resets. Let's start by looking at the sequencer interface.
So ours is dark mode, that's the only thing.
We have two main ways to perform token analysis with sequencer. Live capture, this is the more common method and is the default subtab for sequencer. Live capture lets us pass a request that will generate a token to sequencer for analysis. For instance, we might want to pass a post request to a login endpoint to sequencer, knowing that the server will respond with a cookie. With the request passed in, we can instruct sequencer to start a live capture. It will then automatically make the same request thousands of times, storing the generated token samples for analysis. After collecting enough samples, we stop the sequencer and allow it to analyze the captured tokens. Manual load, this allows us to load a list of pre-generated token samples directly into sequencer for analysis. Using manual load means we don't need to make thousands of requests to our target, which can be noisy and resource intensive. However, it does require that we have a large list of pre-generated tokens. We will be focusing on live captures in this room.
So, we already have the one we caught. So if we send this to a sequencer instead. In the token login within response section. Since we're testing the login token in this case, select the form field. Ready button. It does look gray. Yeah. Okay. So, admin login. Okay. Because the other one didn't have the... have any. Let's just... No, this one. I never really use this one anymore. I just look at this. But this is so funny. Why is it jumping? That's just because I spelled username wrong so many times. We have different ones there. So I didn't say if it wanted. This is the login token. I'm kind of thinking they want the login attempt. This says I don't know where on the page I was even. Capture a request. That's what it say. I'll right click it and send to a sequencer. Let's remove that one. And no, we still can't click the form field. Hmm. That's the wrong one. Hmm. So, let's look at them. Is it really this one that you want? Yes. So, because it has the response too. Oh, I shouldn't almost lie down. So, cookie form field custom location. We can simply leave all options at their default values, click the start live caption, because we want to see if this is actually random then. Oh, we're supposed to catch about 10,000. A new window will pop up indicating that a live capture is in progress and displays the number of tokens captured so far. Wait until a sufficient number of tokens are captured. The more tokens we have, the more precise our analysis will be. Once around 10,000 tokens are captured, click on pause and then select the Analyze Now button. So, we're at 3,000. So, let's read the rest. It's important to note that we could have also chosen stop the procedure. However, by opting to pause, we keep the option to resume capture later if the report doesn't have enough samples to accurately calculate the token's entropy. If we wished for periodic updates on the analysis, we could have selected the Auto-Analyze checkbox. This option tells Burp to perform the entropy analysis for every 2,000 requests, providing frequent updates that will become increasingly accurate as more samples are reloaded into the sequencer. At this point, it's all worth noting that we could choose to copy or save the capture tokens for further analysis at a later time. Upon clicking the Analyze Now button, Burp will analyze the token's entropy and generate a report. And seriously, when I was reading, I was solving a problem with my kids. Parent brain, I guess. So, I know what to do with that thing now. So, let's pause. Overall results estimated to be excellent. I think that's probably okay. I was like, I have never typed this word. Excellent. Excellent sounds. I don't know why I don't use it. Excellent. Oh, well, now I know how to spell it. We're learning English, right? I'm actually eating off my muesli. So it's like... Oh, that was a real hard one. Grains of different things. I think I wanted something more to chew on, you know. So analysis. Now that we have a report for the entropy analysis of a token, it's time to analyze it. The general entropy analysis. The report is split into 4 primary sections. Yeah. Well, it looks like that. So I'll just TTS the rest of it and
overall result.
continue.
This gives a broad assessment of the security of the token generation mechanism. In this case, the level of entropy indicates that the tokens are likely securely generated. Effective entropy, this measures the randomness of the tokens. The effective entropy of 117 bits is relatively high, indicating that the tokens are sufficiently random and, therefore, secure against prediction or brute force attacks. Reliability, the significance level of 1% implies that there is 99% confidence in the accuracy of the results. This level of confidence is quite high, providing assurance in the accuracy of the effective entropy estimation. Sample, this provides details about the token samples analyzed during the entropy testing process, including the number of tokens and their characteristics. While the summary report often provides enough information to assess the security of the token generation process, it's important to remember that further investigation may be necessary in some cases. The character level and bit level analysis can provide more detailed insights into the randomness of the tokens, especially when the summary results raise potential concerns. While the entropy report can provide a strong indicator of the security of the token generation mechanism, there needs to be more definitive proof. Other factors could also impact the security of the tokens, and the nature of probability and statistics means there's always a degree of uncertainty. That said, an effective entropy of 117 bits with a significance level of 1% suggests a robustly secure token generation process.
I do have training ache in my legs, which is nice, because I want to get in better shape. So, I just click the question there. The organizer can be module of Burp is designed to help you store and annotate copies of HTTP requests that you may want to revisit later. Let's TTS it too, cause
this tool can be particularly useful for organizing your penetration testing workflow. Here are some of its key features. You can store requests that you want to investigate later, save requests that you've already identified as interesting, or save requests that you want to add to a report later. You can send HTTP requests to Burp Organizer from other Burp modules such as Proxy or Repeater. You can do this by right-clicking the request and selecting Send to Organizer or using the default hotkey Ctrl+O. Each HTTP request that you send to Organizer is a read-only copy of the original request saved at the point you sent it to Organizer.
I'm just curious what we could use this for, right? What? Requests are stored in a table which contains columns such as request index number, the time the request was made, workload status, Burp tool that the request was sent from, HTTP method, server host name, URL file path, URL query string, number of parameters in the request, HTTP status code for response, length of the response in bytes, and any node that you have made. So we can make a note there. Can we make a note here? So we just type something. Okay. I've not seen anyone use this, right? To view the request and response, click on it. Read only. Yeah. So, congratulations on completing the Burp suite other modules room. To summarize, the code allows you to encode and decode data, making it easier to read and understand the information being transferred. Comparer enables you to spot differences between the data sets, which can be pivotal in identifying vulnerabilities or anomalies. Sequencer helps performing entropy analysis. This could be good, I guess. Providing insight into the randomness of their generation and consequently their security level. Organizer enables you to store and annotate copies of the HTTP request. I think, will these even be stored? I don't think so. They will just be gone the next time you open the program, right? So, having a fundamental understanding of these tools equips you with a broader skill set when it comes to web application penetration testing. So there's one more room in this series.